These notes provide an introduction to using and coding functions. All programming languages provide some form of functions. These notes will explain the purpose and power of using and coding functions in Python. Let's get started. The truth is that we could stop learning any more Python after Chapter 3 and still solve any problem given to us. I'll wait till you stop laughing. You probably don't believe that about yourself yet, but it is possible. You have enough Python knowledge and tools. You just need to practice, practice, practice. However, before you go and get a drop slip, let me explain about functions and why you really should stick around and complete the course. Let's consider functions from a theoretical point of view by asking questions of them. What exactly is a function? In Python, it is a named unit of code that consists of a related set of instructions to perform a single task. In general programming terminology, it is called a subprogram. Why should we use functions? Well, it makes thinking about the problem and coding a solution easier. We can better organize our solutions. We can reduce repetition of code. And it's easier to find and fix problems and grow the program by adding features and refinements when we use functions in our program. Where do we put them? Well, we need to define a function before we call it. It can be used anywhere in code that a like value can be used. If the function doesn't return a value, then it can be used on a line by itself. When should we use them? Well, we should use them from now on. And how do we use them? Well, we need to give it a unique name, define it, and then call it. We're using a structured design and an input processing output approach to programs. We are now going to use this input process output approach to our subprograms that are called functions in Python. We will break our input section down into an input function, our process part of the program down into a process function, and our output portion of the program into an output function. Since we describe a function to be a subprogram, a good starting point for organizing our program solutions is often to map out the input processing output strategy. We can now apply that same idea to the parts of the program, setting them into their own mini-programs, so to speak. We will take the input part and build its IPO, and do the same for the process and for the output parts of the program. We will always use a main. The main function will serve as a driver. Main should contain the calls to the functions in the order they need to be executed. Think of it like an outline for solving a problem. Similar to the table of contents in a book, it shows us the big picture of what our program will do and the order of actions. The details will mostly be inside the functions. Notice the structure. The actual call to main is at the bottom. Why? Well, this is because of function scope rules. Python requires that we define function main before we can call it. At each subprogram or function level, we can use the same IPO strategy that we use for the overall programming project. We need to think about each part of the program individually and how it fits in with the rest of the program to form the overall solution. Therefore, we will think about each part of the program initially as a black box and apply our IPO strategy. Although the black boxes in our slides are green boxes. Recall our IPO strategy. First, consider what this part of the program needs to produce as output. then consider what the inputs to the Python function will be, apply our subtraction to determine the necessary process steps that will become our coded instructions. Here is the coded main for the sample solution we will use. This is not the only possible solution. Everyone has their own unique approach to solving programming problems. I used 4 functions, and I formulated them in a way to demonstrate the 4 options we have in terms of IPO. Let's examine them more closely. We see the instructions function, the input team info function, the process winning percentage function, and the output winning percentage function. Here are the 4 variations on functions. 1. No inputs and no outputs. There are only processing steps. 2. No inputs with outputs. So we process and produce output. 3. We have inputs and we process, but we don't produce any outputs. And 4. We take inputs, process, and produce outputs. When we consider these, we need to keep the perspective that we are inside the box, so to speak. Think about what the specific individual task is for this part of the program. It's best to keep functions as small and single-purposed as possible. Do one thing and do it perfectly. Keep the focus narrow for each unit of code. So how do we decide? It comes with practice and looking at good code to get ideas for structuring our solutions. We are looking at a possible solution to the putting together the pieces program number 1 on winning percentages. It has been organized into 4 parts, and each one of these parts will demonstrate one of the varieties we see here. The first one we will examine is the no input, no outputs, strictly processing. This is useful when we are providing instructions to the user. This function needs no inputs and produces no outputs in relation to the rest of the program. Its only job is to explain the program to the user. Sitting inside the instructions box, we see that we don't need any information from another part of the program to print the instructions to the user on the screen. Although we print to the screen, we are not producing output to be used by any other part of the program. Notice there is no return statement, and there are no input parameters inside the instructions parentheses. The second variation is no inputs, but producing outputs. Remember, our point of reference is inside the green box looking at the rest of the program code. Our job is to get inputs from the user, not another part of the program, so there are no input parameters inside the parens for input team info. Although we accept inputs from the user of the program, this function has no formal input parameters. All of the input is from outside the program, typed in by the user. However, our job is to provide the rest of the program with the information we solicited from the user. Therefore, we must provide 3 pieces of related information to the rest of the program: the team name, the games won, and the games lost. So we bundle this related information into a tuple and return it from function input team info. This is a common practice. Have a getUserInputs type of function that has no formal input parameters but provides output to the rest of the program. We see at the bottom of this function the return input info. The third function option has inputs but no outputs. Again, we climb into the output winning percentage function box and look at the rest of the program. That is our perspective when we formulate the design of the function. This function's purpose is to provide the output to the screen for the user after the calculations are completed. It needs information from another part of the program, hence the formal input parameters of team name and winning percentage. Although it will write output to the screen, it does not need to send any information back to the rest of the program. Therefore, it has no return and no specific outputs. The fourth and final version of functions in terms of input, process, and output is a function that takes inputs, processes, and produces outputs. Frequently, the processing part of the code will require inputs to perform its task and also produce outputs for the rest of the program to use. Note the use of generic naming conventions for this part of the program. This is a good idea so that your functions can be used over and over again, perhaps in other programs and/or by different parts of the program you are currently writing. So our input parameters are called wins and losses, and we see that we return the winning percentage from function process winning percentage. Now it is time to take a look at main. Here is the main function. We will always use the main function to be the driver of the program. It should call the function step by step to complete the programming problem. This is a small program. It ordinarily would not need to be organized into separate functions, but it provides us with a useful example of how to design a solution into parts, and it allowed us to examine the four varieties of functions in terms of inputs and outputs. We note that it is a little surprising that our input part, function input team info, actually has no formal inputs and is just an output function. Notice that our output functions show up on the right side of assignment. Why? Because they are providing a result for the rest of the program to use. Input team info sends back a tuple of team info to the rest of the program, providing the name of the team, the games won, and the number of games lost. The process part frequently takes inputs and also produces outputs. Here we see that function process winning percentage has two inputs, the number of games won and the number of games lost. Its job is to use that information and produce the result winning percentage as output. Again, notice that the output from this function is being used to assign a value to variable win percent. Win percent will be passed as input to the output winning percentage function. Here is the structure chart for this program. Main calls these three functions pictured left to right. I left out the instructions to keep this simple. They describe their steps below the function. The arrowed lines indicate the flow of variables or data information into and out of each function. Most programming projects are larger and more complicated than the winning percentage problem. Breaking them into their subparts, also known as subprograms, makes completing your task easier. It also allows for teams of programmers to work on a larger project together. Happy coding!